Okay, so we're actually going to start getting into trig today. We're going to start with trig ratios. So in this drawing, you can see that we have an angle in standard position called theta. And then there's a point on the terminal side of theta called xy. Right, so that would be the coordinates of that point. That would be how far over, that would be your x. And then how far up you have to go, that would be your y, to get to that point. And then this distance from the origin to that point we call r. And for any value of theta, these three ratios are going to be constant for any point P on the terminal side of the angle theta because of similar triangles. So in other words, we can use these ratios to define the size of this angle because it's kind of like the fingerprints of the angle. If you know one of these ratios, you can figure out the size of the angle because every angle has a unique set of ratios. And so those ratios are a function of your angle. And you're probably somewhat familiar with these. Once I show them to you, you're going to kind of, I think, remember them. So the ratios are called the trig ratios or the trigonometric ratios. And there are 6 of them. You're probably somewhat familiar with 3, and then the other 3 might be new. The first ratio is called sine, and it is the y over r ratio. Cosine is x over r. And then tangent is y over x. And then these 3 are the reciprocal ratios because they're reciprocals of the main 3. Cosecant is the reciprocal of sine. So cosecant would be r over y instead of y over r. Secant's the reciprocal of cosine, so it would be r over x instead of x over r. And then cotangent is the reciprocal of tangent, so that would make it x over y. A lot of people get confused. They think that cosecant and cosine should go together, but they don't. So just kind of start getting that in your head now that they don't go together. So we're going to use these ratios in some problem situations. So let's look at this first example. This says if the terminal side of theta in standard position passes through point P, draw theta and find the exact value of the 6 trig functions of theta. Okay, so let's start here. So we've got the ordered pair 6, 8. So that means we'd go over 6 and up 8. Over 6 and up 8. And that's on the terminal side of theta. So if we draw the terminal side going from the origin to that point, the initial side would be on the positive x-axis always. Then this is the angle that we're talking about in here. Right in here. This would be theta. So you can see from this drawing that we can make a little triangle here where this side is the x, so this would be 6. This side is the y, so this would be 8. And then this would be r, which we can get by doing the Pythagorean theorem. A squared plus b squared equals c squared. So 36 plus 64, which is 100. So this would be 10. Right? And so now we can find the exact value of the 6 trig functions. Okay, if you look back up at how we defined them in terms of x, y, and r. And so now you should be able to, I'm going to erase this over here, write the 6 trig functions. So let's see. So sine, we said was y over r. So it would be 8 over 10, or 4/5 if you reduce it. Cosine would be x over r, or 6 over 10, or 3/5. Tangent, sorry about the announcement, y over x, so 8 over 6, or 4/3. And then the reciprocals, you just, flip those. So cosecant, you flip sine. So it would be 5 over 4. right? Or remember, it's r over y, so it'd be 10 over 8 or 5 over 4. Secant, you flip the cosine, so it would be 5 over 3. And then cotangent, you flip tangent. So cotangent would be 3 over 4. All right. So let's try another one of those. Hold on just a second. Okay, so let's try another one. So we're going to start with our point. Now don't let the square root throw you off, right? -4 square root of 2. That means that we're going to go left 4 and then up the square root of 2. So we go to the left 4 and then up the square root of 2. That's where this point would be. All right. So x is -4, y is square root of 2, and then we're going to find r. So we're going to do a squared plus b squared equals c squared. So 16 plus 2, which would be 18. So we do the square root of 18, which 18 doesn't have a square root, but if you break 18 down, it's 9 times 2, and 9 has a square root. So this would be 3 square root of 2. The square root of 9 is 3, and then there's a 2 left over. So once you have x, y, and r, you can find all of your trig ratios. By the way, r will always be positive. X and y can be negative, but r will always be positive. And you'll find that when you do the Pythagorean theorem, because it's a squared plus b squared, that's going to give you a positive always. And then when you take the square root, it would still be positive. So, okay, so back to our ratios. So sine is y over r, so 1/3. Cosine is x over r, so -4 over 3 square root of 2. Now, unlike other math classes, I don't really care if you leave a square root in the bottom. However, on a multiple choice standardized type test, they probably are not going to. So remember, to get rid of the square root in the bottom of a fraction, you multiply the top and the bottom by that square root. So in this case, on the top, we'd get -4 square root of 2. And on the bottom, we would get 3 times 2, because when you multiply the square root of 2 by itself, it becomes 2. And then there's a 3 on the bottom also. And then you can reduce that. And then tangent would be y over x. So square root of 2 over -4. Right, and you can't reduce that. I know you might be tempted to, but you can't reduce the number inside a radical with one that's outside of a radical. All right, there, you can't reduce that. So then the other 3, cosecant, you just flip the sign. Remember, sine was 1 over 3, so cosecant would be 3 over 1, or just 3. Secant, you flip the cosine. So remember, we got this -4 over 3 square root of 2. So if we flip it, we'll get 3 square root of 2 over -4, right? If I flip it before I rationalized it. And then cotangent, we flip the tangent. So we'll get -4 over the square root of 2, which if we rationalize that, we get -4 square root of 2 over 2, or just -2 square root of 2. What a mess I made out of that, sorry. Okay, so we're not gonna do the other examples on here. I kind of just want to start with this type of problem where they give you an ordered pair. The other type of problem, you just start off with a different piece of information, but the problem ends up working out the same. So we'll actually go over that probably in another video. So for today, just make sure that you understand these 2 examples.